Hello.
Hello.
Go.
All right.
Nice map.
Thank you. So this is the Northeast. We're defining the Northeast as Maryland and above. This includes D.C., which is in Virginia. It also includes all of the states that you see in the light blue region. Imagine Wall Street flooding this winter. We have no preparedness for this. None of the generators in Wall Street are insulated. All trading shuts down. The traders run around like a bunch of decapitated squirrels and have absolutely no idea what's happening. This is a severe problem. A single day of Wall Street shutting down loses $279 billion in trading and means that every other country surpasses us economically. China, Russia, all of these countries have access to trading sites while our traders are scrambling to get access to any sort of computer that they have, that they're able to. This could end trading for weeks as we attempt to recover and attempt to deflood Wall Street, which would mean trillions of dollars in damages, and that would be irreversible damage for the US economy. Because the US economy is linked globally, as we can see in 2008, this would cause a global economic crash, disrupt all trade, and destroy the world as we know it. We have to act to prevent this now.
We will be presenting several data models throughout this presentation. These data models have been produced by the National Climate Assessment, which is composed of 300 plus experts guided by a 60-member Federal Advisory Committee. This has been extensively reviewed by the public and experts, including federal agencies and a panel of the National Academy of Science. Additional model data sets will be produced by the National Oceanic and Atmospheric Administration, or the NOAA. This first model displays what we know as the historical climate of the Northeast, which has been averaged between the projected ranges of 2041 and 2070, as compared to 1971 and 2000. As you can see on the left, not many days have been over 90 degrees Fahrenheit, but the data to the right shows that the proposed model, the projected model, actually has quite a few number of days that have been over 90 degrees Fahrenheit. This is also the higher emission graph. So this is what we are actually projected towards going. So as you can see, a lot of the Northeast is red, which isn't good. The graph at the bottom shows that some of the places such as Delaware or Maryland have 70 plus days of 90 degree and above weather. This is the lower emission model map. It's not as much as the higher emission, but we can see that there's still a major increase in the number of days over 90 degrees Fahrenheit. What this means is we still need to act on these heat average increases because no matter what happens, we will still have increase in duration, increase in intensity, and increase in frequency of heat waves in the Northeast. Lower emission still has it as 3 to 6 degrees increase by the 2080s. This last model data set shows once again the historical climate of what we have from 1971 to 2000, the projected data from lower emissions to the left of that, and then to the farthest left is the higher emission data set.
Pretty easy to see. Less red, more red, even more red. That demonstrates that the climate is getting warmer in the Northeast, without a doubt, regardless of which emission set we use. It is getting warmer. There's no evidence to dispute that.
Another reason why the Northeast is particularly vulnerable is because a lot of it has high-density urban coastal cities. There are 64 million people inhabiting the Northeast. That's a lot of people in the United States to be affected by this increasing drastic average temperature. The urban areas, as you can see on this graph, are actually about 10 degrees hotter than the surrounding forested areas. For this example, we see Manhattan contrasted against Central Park, the blue areas. Because of this, we will see greater impacts in health and economic later on. Presented later on.
All right, so while we can show you the heat maps, here's the statistical data provided by the NOAA that shows us there is, in fact, an increase in the average temperature during the summers in the Northeast. So here is the baseline from 1895 to 2000, which is about 59.8 degrees Fahrenheit. And then this graph shows from 2001 to 2015. And as you can see, every single year has been above the average temperature from historical data. In 2010, which you can see right here, there's 3.4 degrees Fahrenheit increase from the average, which is extremely high. In 2015, you can see a very similar slope, so similar to the 2010 trend. So there's no sign of any decline in these temperatures in the Northeast. And much like the winter, much like the summers, the winter is also increasing on average. As you can see by most every single data point here is above the historical line. One key point to notice is that these trends that are extremely downward sloping, the polar vortex, which they cause extreme cold, a lot of snow, and winter storms that are way more intense than they were before. But otherwise, besides those polar vortexes, the average temperature is in fact increasing. Okay, and then also the precipitation. The Northeast has experienced a larger increase in extreme precipitation, much larger than any other U.S. region since 1958, which saw more than a 70% increase in the amount of precipitation falling in very heavy events, which are the heaviest 1% of events. Here is the baseline of 42.03 inches, again from 1896 to 2000. And almost every single year since every single year since 2003, it has been above that, which would be good for states like California, which are experiencing heavy drought, but it causes significant problems in the Northeast. Like here, this one is about 10 inches above the average, and this one's about 9, which is significant because when precipitation events occur, they will create a greater flood risk, particularly in the valleys where people in agriculture and infrastructure tend to be concentrated. Okay, along with average precipitation rising in recent years, the North Atlantic sea level is also rising. As you can see here, through the year 0 to about 1500 is pretty, or I guess 1000 is pretty static, and then gradually, but it recently has been extremely rapid in its acceleration. Over a long time, so you can see that this is clearly out of character. Okay, and then here's the projected global sea level rise. As you can see, that here's, again, historical data, and this is the projection right here, this gray triangle. We're projected to go from about 1 to 4 feet above our rise in sea level, but even in the Northeast, it's going to be even higher than that. The large range, because it's 1 to 4 feet, we're not exactly sure how the glaciers and the ice sheets are going to react to the warming ocean, which is definitely happening. The sea level rise will be really significant along the coastal Northeast, and it's going to rise even further. And a sea level rise of 2 feet, that any changes in storms would more than triple the frequency of dangerous coastal flooding throughout most of the Northeast. Okay, the map on the left shows a bunch of different cities and then their feet per century historical rise. And globally, the sea level has risen about 8 inches, but in Philadelphia, right here, has risen about 1.2 feet, which is an 80% increase over the global average. Increases the risk of impact of critical urban infrastructure in these low-lying areas. Philadelphia is not the only city that's having this issue. Plenty of these other cities will definitely have major issues with the rise in the sea level. On the graph on the right, you can see that over the past 10 to 15 years, there's increasing at a much greater rate. So it's right here, it's extremely high, a lot of very high sloping graph right there. And then,
Okay, so this is another case study of a model data sheet. This was produced to project what would happen for such storms as Superstorm Sandy along the New Jersey shoreline. And as you can see, we have a probability range right here, and the dark red points are high probability. Like all along here, this first band is a 91 to 100% probability of happening. What the first band represents, the inside band, is collision of waves, and that's pretty basic. It means that the waves are coming up to the ocean and creating a beach, which is a normal procedure. However, we can see on this middle band, that's the middle band up here, we have something called overwash. And what overwash does is when the waves are they're so high that they invade the shoreline and they actually start doing erosion, which is bad if you're like building along the coastlines. It can wash away homes, businesses, whatever you build there. And as you can see, there's quite a lot of probability of that happening as well, a little bit less. The third band, the outside band, is something called inundation, and that's the worst. Essentially, it means that permanent flooding channels can be created because of this. And this model shows that 21% of the shoreline has more than a 90% chance of actually experiencing inundation, which isn't good because, as you can see, Atlantic City has a few of those bands around it. So what this model can do is it's great because we show data models and that's knowledge, but we can take this data model and we can translate it into ways we can economically impact and minimize the damages that the coming climate change will bring.
One single week of Wall Street closure is the equivalent of a nuclear detonation in the city of Manhattan. That's trillions of dollars in damages, and it's argued by every economist to be completely irrecoverable. This is what will happen if we don't take any sort of action to mitigate the economic impacts of this issue. The first question, though, is infrastructure. And just the cold, the heat, and the flooding will have dramatic damages to infrastructure. You'll have collapsed homes and power plant failure in the winter when the infrastructure is unable to support any sort of low temperature. You'll also have a destroyed city transportation. If the New York subway is flooded, for example, millions of people depend on that to go to work, which in and of itself would shut down the economy of New York. Additionally, city transportation could take months to repair, which would drastically impact economic productivity. The main point is that all of the data sets that we've shown earlier have an individualized economic impact that is severe. If you look at trade disruption, that's the Wall Street example, or take, for example, Washington, D.C. being flooded, which would make all policy decisions essentially grind to a halt for weeks or maybe even months. You also have specific industries shutting down. If you take the Port of Baltimore just itself, a 2-foot rise in sea level would cost only the Port of Baltimore over $165 billion. Additionally, if you combine this with 5 other major ports in the region, this would lose the US more money than our entire yearly defense budget. We do not have that kind of money available in order to hedge against these economic impacts. Additionally, airline flights in the entire Northeast could be grounded by a major storm. Up to 25% of all US air traffic comes through this region and would not be able to take off in the event of a major climate disruption. You also have health impacts. If you look here, the projected number of days over 100 degrees Fahrenheit in the Northeast United States is going to increase tenfold over the next years. The Union of Concerned Scientists says that this will cause heat wave deaths to dramatically increase. There are currently already thousands of people dying from heat waves, but if you take a tenfold increase, that number grows immensely. Additionally, storms and flooding by themselves individually kill many people, but the main problem is when the two of them are combined. If you have major flooding coupled with a storm like Superstorm Sandy, not only does the flooding inundate the buildings by itself, but the superstorm brings additional water, which would cause the damage to be amplified. 13,000 people have died only from winter storms in the past 5 years. Couple that with the damages from Sandy, which cost billions of dollars. Couple that with the close to 100 heat wave deaths in specific states. That is all going to be amplified as the years go on. This is an issue that will affect tens of thousands, potentially hundreds of thousands of people in the coming years. Additionally, when the climate warms, as we've demonstrated that it will, diseases will spread and become more prevalent in these areas. Specifically, malaria is likely to become able to be transmitted in the Northeast, which people predicted would never happen because the climate isn't warm enough for them to survive. You also have new cases of something called Lyme disease that has tripled in the past 10 years in the Northeast. This all indicates that the warming climate not only will have a dramatic economic impact, but will also cause health impacts that will be irreversible.
So the bottom line in all of this, we need to protect our public infrastructure, the public health, agriculture, transportation, energy systems. All of these things could be impacted, will be impacted. But, and at the bottom line of all of this is the economy. And what is one of the most important things to maintaining our position in the globe right now is maintaining our economy. The good news is that we already know the steps to help mitigate against this. For example, labor, building seawalls, fortifying. We already have the public body able to do this. We have about 5.5% national unemployment rate. If we put those people to work, building more infrastructure, reinforcing the infrastructure in the Northeast that's some of the oldest in the country, building new seawalls, protecting our levees, not only would that help our economy by minimizing unemployment, those people would pay back the money that we spend to put them to work with public projects. They would invest in the economy. They would not cost for public services as much as they do on unemployment. That would be a huge boon economically, and it would make us safer in the long run. Some other things. Technology. We already know what we can do to start mitigating against these things. Enhanced heat detection. That's something that they've started in Philadelphia. And they have warning systems put in place. It used to be the heat wave capital of the world in 1995. Emergency systems and an emergency plan has city workers that go out and tell people, hey, it's going to be really warm. Here are some cool places. Those cool places funded by the city are open longer, and water utilities are prevented from shutting off their taps because people can't pay, to protect the public health, make sure people are being hydrated in intense heat waves. Things like
if you look at the levies,
Oh,
these levies alone, when we invested $100 billion in 2011 to repair our levee system, that same year, the levies saved 141% of their cost. That's 1/6 of our total defense budget that would be lost if we don't take steps now to remodernize and rebuild our levee system. It's a $100 billion investment, true, but it returns that same amount in the exact same year.
Things like, for energy, we have technology like combined heat and power technology, which enables places like hospitals in New York and Texas that have already started this. They bring in fuel on site, they produce their energy, but then they also get to capture the heat from that. It's 75% efficient in comparison to the 40% efficiency of drawing in energy off the grid. And they can sell back excess energy to the grid in order to help stabilize the grid system when, during these intense periods of cold in the winter or the intense periods of heat in the summer, energy spikes because there's so much demand residentially. Again, we already have the money to help to offset these costs. The webs of cooperation have been found. These are industries like the fishing industry, the timber industry, people who are starting to feel the effects of these warmer temperatures or the colder temperatures that are ready to invest to help find solutions. We have the people, they're in our workforce right now, they're unemployed, let's put them to work. We have other people to help us invest to help offset the cost for this, and in the end, it will pay for itself.
Climate change is currently happening in the Northeast, that's indisputable. It will also have devastating economic and health impacts if we don't act now. Potentially trillions of dollars lost, our entire economy collapsed. And taking action now is what's necessary to prevent the worst consequences. It's far cheaper to make an upfront investment than to worry about deflooding or draining Wall Street after it's already been flooded. Our proposals are simple: $100 billion for the levees, and a re-modernization of our energy infrastructure in order to make it more insulated against winter storms. As you may remember to our presentation to your sister committee, CSUC, the insulation of those power plants would recoup over 200% of the money that we would put in. So put in $100 million, the next year you save $200 million. Additionally, all insurance companies are already budgeting for this to happen in the future. They're raising their rates now. They know how expensive this will be if there's not action taken right now, which means that if you allocate $100 billion, maybe $120 billion to this issue now, that will return enough money over the long term to prevent the entirety of our defense budget from being drained. We can do this. It's easy if we have the money available now. It's very difficult if we wait until the issue has already come up. Thank you.